Welcome back to the discussion of spatial query languages. In last few videos, we talked about the notion of queries, query languages. We went through basic old SQL, and we also saw how tedious it was to model spatial data in queries in old SQL. And then we saw the OGIS, which simplified many of the basic queries. So in this video segment, the goal is to get into more depth of OGIS, and in particular use OGIS topological operators for spatial joins. Okay. So we will look at spatial join queries to understand their output, and hopefully it will also help you compose simple OGIS queries which use spatial join. Okay. So in the last video we saw simple OGIS queries which did not use spatial join, but we saw operators like area, we saw operators like distance and so on. And in this particular video we are going to do spatial join using set of topological operators such as touch and cross, and we will also show the use of this topological operation with aggregation such as the group by clause as well as some nesting. Okay. All right. So let's start with the first query which needs spatial join. Okay. So this query is looking for rivers and countries. So it's looking at pairs of rivers and countries, and the relationship is a spatial relationship. So we want these rivers to be crossing through the country. So for example, if you look at the river Nile, we do want, let's say, Egypt to be listed with Nile, but we don't want Congo or Nigeria to be listed with Nile. Okay. All right. So first question again, in such queries is which tables are needed, and it can, from the English text you can see river tables are interesting as well as the country table is interesting. So those two tables have to be listed. The second question, if you remember in our query formulation video, said how do you combine these tables? So that rows in country table and rows in river tables, how should they be paired? We don't want all combinations clearly, right? So which combinations are valid? And in this case, those combinations are specified by spatial relationship. So you have to think through the topological relationship and ask which topological operation allows me to intersect, a river and a country. Okay, and that was the cross operator. Okay, so if you remember, cross was an unusual operator. It took a line string, maybe the center line of a river, and a polygon which may be the footprint of a city or a country. In our schema, the country footprints are polygon and cities are approximated as points. Okay. So cross operator is used, and that's the condition. So if we did that, it will essentially start with all possible pairs of rivers and cities, and it will throw away all pairs where this predicate is false. Okay. So you will be left with pairs such that the rivers cross the country. Okay. So again, to recall the essence, this cross operator is used for join here. Notice that it is in the where clause and it involves two different tables. So it is joining the tables, so it is a join operator, but since the condition is a spatial condition, it's called spatial join. In contrast to various joins you saw earlier, in the old SQL we only showed you equijoins, where you said, let's say, city.country is equal to country.name. It was a very simple equality predicate matching exact string values. Okay. In contrast, this join predicate is more sophisticated. It's doing a geometric, intersection or between a line string and a polygon. Okay. All right. So let's continue our journey and see some other examples of spatial join. So next one, we are going to look at the query where we are essentially talking about countries, and we want to see the neighbor relationship among, between or among countries. Okay. Again, if you are a geography buff, you may be intrigued by geography quiz questions such as which country in the world has highest number of neighbors. Okay. So what we are doing right now is not as sophisticated, but you can build on this to answer that. Okay. Yeah, just if you were curious, this country is in Asia, one of the large Asian countries. Okay. All right, but coming back to this query, first question, which tables are needed? And this case we see the country table, and that's about the only one we see now. Okay. So certainly you want to work with country table, and then we are picking up this country, but in order to model these neighbors, we may need this country table twice. Okay, because a single country table does not have information about neighbors. So the only way to compute neighbors is to take two different countries, look at their polygons, and somehow look at their spatial relationships. So again, you may want to ask which OGIS operator takes two polygons and tells us whether they are neighbors. That means the boundaries overlap, but interiors don't. Okay? Even if those countries think they do, but they don't. In OGIS, the interiors don't overlap for neighbors. Okay? So if you again think through that, that operator is touch. So we are, in this case, the condition for join is touch, and you are looking at the shape of two countries. Okay? So if you want to read this particular query, then you start with the from clause, and it takes country table twice. And by doing so, it would essentially make pairs out of country. Okay? So all those pairs will be formed, and then we'll throw away any pair where the boundaries don't intersect. Okay? And then what we'll be left with are the pairs where boundaries intersect. Okay? And then finally, in order to restrict the answer to USA, we'll add one more condition on the country name on one of these countries. Okay? So this will give you a list of pairs of countries where boundaries intersect. Now, if you are really looking for details here, then you may find one small issue with this answer. So if you think about the, let's say country USA, will that be in the list of this answer? And it may be, because there will be a pair which takes USA from first copy of country, USA from second copy of country forms a pair, and the boundaries will intersect. So it's a good question to ask, when that happens, will OGIS declare it to be neighbors or not? Because in this case, interiors also intersect. Okay? So this will be a good learning exercise for you to try it out and figure out in OGIS if interiors intersect and boundary intersect, is touch true or false. Okay? And it's an exercise left to you. Now, in terms of join, there is another thing to think about here, which is that in this case, this join is happening with the table and itself. So such join are often called self join. Okay? So in this case, you have looked at a special case. It's a self join using a spatial predicate. Okay? Great. So let's continue our journey and look at another spatial join with a different topological predicate, and in this case we are going to bring in also a metric kind of operator. Okay? So the English query is here. So suppose we are given a river, in this case St. Lawrence, and let's say we are given also a threshold. So we want to find things which are within 300 kilometers of this river. So this river center line may be a line string. Now in geography there is a notion called buffer. Okay? And if you are coming from computer science, you may see a different meaning of buffer. So we are not meaning this hardware or graphics buffer here. We are meaning geographic buffer, and that geographic buffer represents an area around this river or a city which satisfies the distance predicate. Okay? So you can create a buffer around St. Lawrence River to answer this query, and once you have that buffer which represents some sort of geographic areas covering all points within 300 kilometers of St. Lawrence River, then you can ask which topological operator allows me to pick up all those cities whose city center, their center point is within the buffer. Okay? All right. So to model this in SQL, again we will go through the three basic composition question. So first is which tables are needed. So clearly we see the river table, that's relevant. We also see the city table. Okay? So we will start with these two tables, city and river. Second question, how do we join the tables? In this case, this has some to do with this spatial predicate, which is within 300 kilometers. So you may have two different ways to model it. You could go and look at actually distance operation, and that will be one way. The other one is to work with buffer and use a topological operation called overlap. So which takes two areas and finds if their interiors intersect or not. Okay? So we are going to use that. So here we take this river, and we say draw a buffer of 300 kilometers around it. Okay? And that gives us a one geographic area, and then we look at the city's location and we ask if the city's location overlaps with buffer around river. Okay? And that's one way to model it. So and then finally, to restrict it to St. Lawrence rivers, you can put another restriction. Okay? So in this query, we have shown you another spatial join, and in this case we are using additional operators like buffer in order to model the distance. Okay? So we showed you three different spatial joins, and now what we are going to do is to increase the complexity just a tiny bit and add things like aggregation and nested queries with spatial join. Okay? And again, for the next few slides, you may be better off reading the English query, then putting the video on pause, try to write those queries yourself, and then come back and check with the answers given in the slide, and that will enhance your learning. Okay. All right, so the next query is here. List all countries ordered by number of neighboring countries. Okay, so this is taking you closer to the question I asked, which country has highest number of neighbors in the world. Okay. All right, so we'll at least create this statistic. Okay. So again, if you want to formulate it in SQL, we start by the question, which tables are relevant. So in this case, we notice the table is country, only one. But since we are talking about neighbors, and that information is not in the country table, we'll need 2 copies of country table. Okay. And those 2 copies would have to be joined. So again, try to recall which topological operator you need to pair up countries which are neighbors. Right. And again, you recall from the previous query, it is the touch operator, which means the boundaries intersect but interior doesn't. Okay. Now, once we have done that, then we are going to do counting, because here we have number. Okay. So you now need to think about what are the groups. So this is an aggregate query. So we need to know what are the groups and what statistics to compute on each group. Okay. So one way to define these groups will be the country from the first table. Okay. So group these pairs by the first element, that's the country name. And by doing that, we would have grouped all neighbors of USA in one place, all neighbors of China in another place, all neighbors of Russia in another place, all neighbors of Iceland if it has any in another place, and so on. Okay. And once you have done that, then you have to remember your statistical operators. Okay. SQL had 6 basic statistical operators, such as sum, average, count, and so on. And you can probably guess you are looking for count. Okay. All right. So we are basically starting with country table, 2 copies of that. You are going to join it using touch operator. We saw that before. The new part here is the group by. So you take the first country and form group by that. So the first copy of the country table. And by doing that, you are collecting neighbors of a country together. Okay. And once you have done that, then you compute the statistical function count, and then you can sort it by count. Okay. And this hopefully will give you the answer to which country has maximum number of neighbors. Great. Now, the last variation we wanted to show you is with nesting. So let's go and take a look at that, and then we'll wrap up the discussion of spatial part. Okay. Now, by the way, the query that I just gave you is also an interesting historic query, because when spatial databases came up back in mid-90s, many GIS users would ask the question, so what's the difference between a GIS and a database equipped with SQL and OGIS? And the sharpest answer was to provide them a simple query, which was very difficult to do in GIS, which was mostly point and click graphical user interface based system. And turns out this is one of such queries. Okay, so if you want to answer this in GIS, it is tricky. You can go mouse over each country, and it may give you the number of neighbors of that country by highlighting the neighbors. But this strategy will take you a while, because you will have to guess. You will have to go and try China, and then Russia and Congo, and then after that collect the information and do that. In contrast to that, SQL works with sets. Okay, so the join, a spatial join, cross product, these are able to pair up 2 different sets and then do statistics. So this query is much easier and quicker in SQL than it is in a point and click system. Okay. Great. So coming back to our own exploration of SQL3 and OGIS, we will go to the next one and show you a query with nesting. Okay. So here we are asking for each river, identify the closest city. Okay. So in order to answer this, again you have to ask which tables are involved, and that's the river and city table. And then you ask how do I join them, and then it gets a little tricky because we are asking for closest city to each river. Right. Now notice this closest is an aggregate operator. That was our third question, that if I pair up cities and rivers, will my answer tuples or rows correspond to the rows of arbitrary rows of river and city? And in this case the answer is no, because really we don't want any arbitrary city with a river, but we only want the closest. So what we have to do is, after we pair up rivers and cities, we have to group them by river, and in each group find the closest city. Okay. So you can actually write a single block SQL query using group by and having, but what we are going to do is to use nesting with this. Okay. So in case of nesting, we can break it up in 2 queries. an outer and an inner. In the outer query we can find all the rivers. So here is so here is rivers and cities, and in the outer one, and then we are saying we only want one city to be paired with each river, and the property is that distance of that city to the river is less than distance of any other city to that river. Okay. And that predicate is tested through an inner query, which is essentially asking for this second part, and you say you take another copy of the city table, you take the distance of this city table to the river, we should have had a R1 dot shape here, and then you ask that this distance never is lower than the distance of the first city. Okay. So this quickly shows you a little bit of nesting. Okay. So hopefully this gives you a glimpse of spatial join queries inside SQL3 and OGIS, and that gives you a little bit more depth with OGIS operators. We also saw a number of different topological operators and their use with aggregation as well as nesting. Okay. So we'll wrap up discussion of OGIS operators and data type at this point. In the next video we'll come back and try to wrap up this long discussion on query languages, which included maybe basics, the old SQL as well as the OGIS predicate. Thank you.